So we're going to continue proving identities today. Before we start, I want you to write down these half-angle identities, and when you're ready, pause. When you're ready, press play again, and we will do a warm-up. Okay, so start by proving this identity. Press play again, pause and then play when you're ready to see the answer. Here we go. The hardest part of this proof is knowing which double angle identity to use for cosine, because I have three of them. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. It's also equal to 2 cosine squared theta minus 1. It's also equal to 1 minus 2 sine squared theta. So when I looked at this, I chose to use the one that was involving sine, because I knew that tangent of theta is sine of theta over cosine of theta. And I was hoping to end up with sine of theta in my numerator and cosine of theta in my denominator. So that's why I chose what I did. Sometimes you might pick one that isn't ideal, but you can still work around and get to the right answer. I think this is the shortest way to do it. So what I did was I substituted in 1 minus 2 sine squared theta for cosine 2 theta, and then I distributed the negative 1 in my numerator, and the 1's went away, and I ended up with 2 sine squared theta in my numerator, and I used the double angle identity for sine 2 theta to change my denominator to be 2 sine theta cosine theta. Now, from there, I was able to cancel sine of theta with one of my sine of thetas in my numerator. I was able to cancel my 2's, so I ended up with sine of theta over cosine of theta equal to tangent of theta. You may have done it differently. There's lots of right ways to do an identity proof. You have to follow all the rules of simplifying algebraically and use only identities that we've learned before. There's another half-angle identity I didn't show you, but that was because I wanted you to realize there was a connection between the identity that we just proved and this one. It's a little larger. So if you notice here, this angle is half of these angles. So this is just written in a slightly different way. This is the half angle, tangent of x over 2 is equal to 1 minus cosine of the full angle over sine of the full angle. So that is the connection. Add this to your half angle identities in your notes. Now, here's another proof that I'd like to do. There's a technique that I have not shown you how to use yet. It's called multiplying by the conjugate. In this case, I really can't change my sines to cosines or my cosines to sines because I really only know identities that will do that if I have cosine squared or sine squared. So what we'll do is we'll multiply by 1 minus cosine of x over 1 minus cosine of x. And this again is called multiplying by the conjugate. The idea here is that when I multiply out my denominators, I'm going to end up with 1 minus cosine squared x, and that's actually equal to sine squared x. So moving along, I'm going to distribute my sine. No, I'm going to leave sine out. Sine of x times 1 minus cosine of x. And when I multiply this through, I get 1 minus cosine squared x. And 1 minus cosine squared x is sine squared x. So one of these signs cancels with one of those, and I end up right where I wanted to be. 1 minus cosine of x over sine of x. And these two match. So I'm done. I could have worked on the left-hand side just as easily by multiplying by 1 plus cosine of x over 1 plus cosine of x. The next thing I want you to notice is this. Isn't this the half-angle identity that we just learned? Why, yes it is. So, there's another half-angle identity for tangent. Please add this to your notes now. Press pause and then play again when you're ready to go on. Here's another proof that I'd like you to try. Press pause, try the proof. When you're ready, press play, and we will take a look at the answer. And here we go. Again, we're going to use that technique of multiplying by the conjugate. You notice on the left-hand side, I multiplied by 1 plus cosine of x over 1 plus cosine of x. That allowed me to get to a point where I had 1 minus cosine of x, cosine squared x in my denominator. I distributed secant. So I had secant of x plus cosine of x times secant of x in my numerator. I changed from here to here, 1 minus cosine squared x to sine squared x. And this stayed the same, secant of x. This part changed to 1 because cosine of x times secant of x is 1. Cosine of x and secant of x are reciprocals. Okay, here's another one for you to try. Press pause, and when you're ready to see the answer, press play again. Here's my solution. I worked on the right-hand side. I wrote this at 1 plus cotangent squared is cosecant squared. That is my Pythagorean identity. And then from here to there, I rewrote cotangent of x as cosine of x over sine of x. So I have, this is my numerator, this is what I changed it to. 2 cosine of x over sine of x, and I changed cosecant squared to 1 over sine squared x. Remember I said that when I wasn't sure exactly where to go with things, I changed to sines and cosines and I simplify and hope for the best. Now, that then is my numerator divided by my denominator. So I have 2 cosine of x over sine of x, that's my numerator, times the reciprocal of my denominator, sine squared x. One of these signs cancels with one of those, and I end up with 2 sine of x, 2 cosine of x, sine of x, which happens to be the double angle identity for sine. And now it matches. You could work on the left-hand side just as easily, a little bit of a different order. I thought it was easier to work on the right. But again, lots of ways to solve this problem. Try this one. When you're ready, press pause, and then when you're ready, press play for the answer. So here we go. What side did I work on? I worked on the right-hand side. One of my rules is that if there's something that I can factor, I should factor it. So I factored what was on the right to be 1 minus cosine 2 theta quantity squared. I'm always looking from the right to the left to try to match things. I notice that I need to change my cosines to be in terms of sines and be a single angle. So I used my double angle identity for cosine. I knew that I only wanted sines on the left-hand side, so I used the 1 minus 2 sine squared theta. And then I simplified. I distributed the negative inside. The 1's went away, and I ended up with 2 sine squared theta, and this whole quantity was squared. Then when I square the whole quantity, the 2 becomes a 4, sine squared becomes sine to the 4th, and voila, there is our proof. And right now what I'd like for you to do is check Schoology. I have some more practice for you, and I will see you next week. Have a wonderfully long weekend.